Hello class, this is lesson 1-1, Understanding Fractions. We will be going over proper and improper fractions as well as mixed number format. This is the Learning Needed channel. A request to my students is to remember your reason to pass the GED test. You have taken a great task upon you and it won't be easy, but always keep your reason close to your heart as you get to that GED certificate. Second is don't give up. It's not meant to be easy. It will be tough, but with these lessons and any other resource you find, you will pass the test as long as you keep going at it. And finally, please like and subscribe for more GED content so that I can continue to produce these videos and more. I do plan to do all 4 subjects on my channel, and I can only do that with your support. Thank you in advance. If you are interested in one-on-one tutoring, please check out my website in the description below, and you can sign up for that. And one suggested study material that I always recommend to my students is to use a Kaplan GED test prep book. It comes by years, so as of this video, the latest is 2024 to 2025, but any year will do. Also, this book shows material for all 4 subjects. It's not just math, so this is a great resource to have for all of your studying in all subjects. Also, please note that the only approved GED calculator that you can take with you to the test physically is the TI-30XS model, which is shown here on the slide. If you do not have one, you are not at a disadvantage. You will be able to use a virtual one available in the test. But if you would like to purchase this calculator and the latest version of this book, I have links to purchase both of them in the description below. All right, let's get started. We'll start with some fraction basics. A fraction is made up of 2 numbers, and together they are used to represent part of a whole. The 2 numbers that it consists of are the numerator and the denominator. The number at the top of the fraction represents how many parts you are working with or how many parts you are talking about, and the number at the bottom is the denominator, and it represents how many parts make up the whole. Here's a visual representation of a rectangle made up of 4 parts, and here we see that 3 of them are shaded. The number at the top, the numerator, is talking about how many are shaded in this case, and it is 3. And the number at the bottom is the denominator, which represents how many pieces make up the whole. And the important thing here to note is that the denominator does not care about which pieces are different than the other. It doesn't care which ones are shaded or unshaded or whatever the GED math problem is asking you about. The focus is that the denominator is talking about how many pieces make up one entire thing, and the numerator is talking about which ones you need to pay attention to based on what the test is asking you. Fractions come in 3 formats. The most common format that you will see is the proper fraction. A proper fraction always represents quantities less than 1, and in order for this to be true, the numerator is always a number of value less than the denominator. So if we see here the rectangle we saw earlier, the numerator is 3, which is a value less than 4. And again, looking at the shaded portion, it represents that the amount of shaded portions is less than the number of pieces that it makes up. The next format of fraction that you will see is an improper fraction. As its name suggests, it represents values that are equal to or greater than 1. And in order for this to be true, the numerator is a value equal to or greater than the denominator. So looking at these images here, first at this rectangle made up of 6 pieces where all are shaded in, the rectangle on the left, the numerator represents how many of these pieces are shaded in. And we see here that 6 of them are shaded in. That would be the number at the top, 6. And the number at the bottom represents how many pieces make up that entire rectangle regardless of whether they're shaded or not. And that is also 6. If you look at the shape on the right, it is actually 2 rectangles. They each are made up of 6 pieces, but the amount of shaded portions is 10. The number at the top, the numerator, is talking about how many are shaded in, and that would be 10. And the number at the bottom represents how many make up one of those rectangles. Not how many pieces make up all the rectangles that you see, but how many pieces make up one of those rectangles. And if we look at the fraction format, here's what it looks like. It is very important that you distinguish for improper fractions the correct value for the denominator. You may see a question where it has 3 rectangles or 4, and you may have a thought where you want to count all the pieces regardless of whether they're shaded or not and use that as a denominator, such as I see here that there are 12 pieces that make up both rectangles, and I might be inclined to put in 12. but it is only talking about how many pieces make up one of them. And the last format of a fraction that you will see is called a mixed number. A mixed number, also like an improper fraction, represents values that are equal to or greater than 1. But the mixed number consists of three numbers. It is the whole number piece, and then just like the proper and improper fraction, a numerator and a denominator. So it looks here in that format where there's a big number in the front and then a numerator and denominator. Mixed numbers and improper fractions are interchangeable. They both represent the same values. So looking at the two rectangles again from the improper fraction section, looking at this fraction of 6 over 6, this entire rectangle is shaded in, which means that it would be represented by just the whole number piece of the mixed number. And we would say that we have one entire thing. And then looking at the fraction at the rectangles on the right, the 10 over 6 fraction, we see here that we have one entire thing. And then we have the leftover piece where there are 4 pieces shaded out of the 6 that make it up. And that is what the mixed number format would look like. 1 and 1 and 4 over 6. So let's look at some example problems of writing proper, improper, and mixed number fractions. Each shape is its own, so you'll see here that there are actually 5 problems in total. The first section is to write a proper fraction for the shaded portion of each diagram. And seeing proper fractions should confirm that the amount of shaded portions is less than the amount of pieces entirely. And you see that is correct for all 3 shapes here. In this first shape, we have that it is made up of 4 pieces and 3 of those are shaded. The numerator talks about how many we are looking at, and we are looking at shaded portions. And for this first diagram, we see that 3 of them are shaded. For the denominator, we are looking at how many pieces make up the shape, regardless of how many are shaded or unshaded, and that is 4. So that is the proper fraction for this first diagram. For the second diagram, using the same logic, we see that one of the pieces is shaded, so that is the numerator, and it consists of 3 pieces, and that is the denominator. Similarly, for this last portion, we see that 3 of them are shaded, and it is made up of 6 equal pieces, so the answer is 3 over 6, and that is proper fractions for these shaded diagrams. Next, we are going to write an improper and mixed number for the following diagrams, and here it is 2 diagrams, the blue and the yellow. Looking at the blue on the left, I will first count how many are shaded in total. And if I count here, there are 7 pieces that are shaded in. For the denominator, the fact that you're writing improper and mixed number formats should tell you that the denominator has to be a value equal to or less than the numerator. So the denominator should be 7 or less in order for it to qualify as an improper or mixed number. The denominator asks how many pieces make up one of the shapes that you see here, and looking at just one of them, I see that it is made up of 4 pieces, so the denominator is 4. The mixed number format is a different representation of an improper fraction. They both represent the same thing. And for a mixed number, I count how many entire pieces are completely shaded in. And I see that one of them is completely shaded in, and that is the whole number part, or the big number in the front of the mixed number. And once we count all of the ones that are completely shaded in, we are done with this shape, and we look at what is left over, and we have one shape where 3 of them are shaded in, and again the denominator does not change. It is a shape made out of 4 pieces. And you'll notice for improper and mixed number formats, they always have the same denominator. So really what you're changing is the numerator or the whole number and numerator piece. Now let's look at this yellow diagram. Here we'll start with an improper fraction format, and I ask how many are shaded in? How many pieces are shaded in? And I say that there are 3 at the top and 6 at the bottom, so that 6 plus 3, or counting them, is 9 are shaded in. and how many make up one of those pieces. So if I don't look at one of them, or if I only look at one of them, only looking at one of these shapes, it is made up of 6 pieces. So the improper fraction format is 9/6. Looking at the mixed number format, again, I ask how many are completely filled in? How many pieces are completely filled in? And I see here that one of them is completely filled in. So that is the big whole number piece. And then for the piece that is not completely filled in, I look at it as a regular proper fraction, and I ask how many are shaded in, and I say 3, and the denominator does not change, but again, the denominator is simply asking how many pieces make up one of the pieces, and that is 6. So the improper fraction is 9/6, and the mixed number fraction format is 1 and 3/6. So that was fraction basics. In the next lessons, we'll be diving deeper into fractions. Thank you guys so much for watching. I hope this helped, and I'll see y'all in the next video.